Hello, welcome back to our last lesson in solving radical equations. For this capstone lesson, the problems are not going to be incredibly difficult, but we are going to switch and do a few problems dealing with geometry. I think it's important, at least some of the time, to show practical application. So we're going to do some problems from geometry that have radical equations that need to be solved. So for our first problem, it's a simple looking problem. If the area is 12 of this triangle, find the value of x. So this is similar to a problem we did in the last lesson, but now we're given that the area is equal to 12, and we want to figure out what the value of x is. So what you have to do is write an equation relating the area to the variable x. So how do we do that? Well, what is the area of a triangle? We know that the area of a triangle is always 1/2 times the base times the height, all right? Now, the base of the triangle we can consider to be x. The height can also be x. This is a right triangle, so this is the height of the triangle. So it looks like it's really easy, right? You could just say, well, the area is equal to 12 is equal to 1/2 times the base is x times the height is x, right? And so at this point in the game, there's nothing to do with the square root of 2. We don't need that square root of 2 anywhere. This is a simpler problem than initially looks. So let's go ahead and multiply this out. 12 is equal to, what we'll have is 1/2 times x squared. Right? So how do we solve for then x? We have to multiply both sides by 2. So if we multiply this by 2, we'll get a 24. On the right-hand side, we'll just still have the x squared. Right? So we'll take the square root of both sides. X is then going to be equal to plus or minus. We have to add the plus or minus square root of 24. Right? So if we then go over here and figure out what the square root of 24 is, let's write the factors down. We have 2 times 12, and then 12 is 2 times 6, and 6 is 2 times 3. So we only have one pair, and then we're going to have 6, 2 times 3 under the radical at the end of the day. So we're going to have plus or minus, and then this resolves to 2 times the square root of 6, right? However, what this actually means is that x can be 2 times the square root of 6, or x can be equal to negative 2 times the square root of 6. But since we're dealing with triangles, the length of the side of this triangle really can't be negative. So this is not valid. Or you could say it's not physical. So really, this is the only answer. So you have 2 times the square root of 6. And that's the final answer. Only one solution there. So pretty easy problem to start out with, but sometimes, you have to remember, first of all, that the area of a triangle is 1/2 base times height, and then apply it to what we're doing. Now, this is a slightly more involved problem, and then the last problem that we're going to have will be involved a little bit more complicated still. But these are all worth doing, so follow through it here with me. What we're given is an isosceles triangle. That means that 2 of the sides are the same length. Now, notice that this side and this side are the same length, but I haven't labeled them. I don't know what they are, but I know that they're the same length. The height of this triangle is x, and I know the width of the entire base here is 10, and I have these letters here because I'm going to be using them. So PQR is isosceles, we said that. QR is equal to 10, so that means QR is equal to 10. We have that labeled in the diagram already. And PN meaning the vertical height there, is just equal to x. So we've actually written down everything over here on this side that is already labeled in the diagram. So we want to find PQ. We want to figure out what this is, right? We want to find out what that is. How can we figure out what that is? Well, we have to go and first figure out a few things that we can find from the drawing. Essentially, what we can do is we can use the Pythagorean theorem, right? Remember from Algebra 1 or from geometry, the Pythagorean theorem gives you how the lengths of the sides of a right triangle are related. Now, notice that this triangle here on this side is a right triangle because we have a 90-degree angle. Also, this side is a right triangle as well. So anytime you have an isosceles triangle, when you split it in half, you're going to get 2 right triangles. So in order to do the Pythagorean theorem with this side, which is what I want to do since I'm looking for PQ, I need to know the length here. I'm going to call it QN. So I'm going to say that QN is not given to me in the problem, but I know since it's isosceles, it has to be 10 divided by 2. 10 divided by 2, which means it has to be equal to 5. So this length is this length here, QN, is equal to 5. I do not know what this length here is equal to, but I'm trying to figure out what PQ is in terms of x. That's all I can really do. So let's go ahead and apply the Pythagorean theorem to this. What the Pythagorean theorem says is that the length PQ, right? So I'm going to write it down like this. PQ, quantity squared, is equal to, so that's the length of the hypotenuse, is equal to this length squared plus this length squared. So x squared plus the 5 squared. That's